The determinant value will be the same value. Fine. Now, let's see one another property. Delta is 0 if all the elements in a row and column are 0. Okay, so determinant will be 0 if you have 3 elements 0, then A, B, C, then D, E, F. Because in this case, all these 3 elements will be 0. Okay. Again, you can have 0, 0, 0 in the second row also. A, B, C and D, E, F. This will also be 0. Fine. Because you can change these two and the delta will remain the same. Fine. Now, one is this, and of course, if two rows or two columns are proportional to each other, then also the delta will be 0. If like A, B, C, then 1 by 2A, 1 by 2B, 1 by 2C, and D, E, F. So, what we are going to do? We take the half common from this row. So, if you take a constant common, then it will become half of A, B, C, A, B, C, D, E, F. If two rows are same, then the determinant is 0. Fine? Because we can subtract them and determinant will remain same. So, if you subtract them, then this will become 0, this will become 0, this will also become 0. So, if you have 3 elements as 0, then the matrix is, then the determinant is 0 from this property. Fine. So, you can have one other property we discussed here is that you can take a constant out of one row, single row, then a single element will be there. If half was here also, if you take this half also common from here, then it will become half into half. Fine. So, you have 1 by 4 on the outside. So, this is something, one property. Then the next property is that if you have a determinant of the form which can be expressed as the sum of A plus A dash, A1 plus A1 dash, then A2, then A3, then you have B1 plus B1 dash, B2, B3, C1 plus C1 dash, C2, C3. If you have determinant like this, then you can break it down in sum of 2. So that will be A1, then A2, then A3. These two will remain same, these two columns, but these two will separate out. So A1, B1 and C1, then B2, C2, B3, C3, plus determinant of A1 dash, B1 dash, C1 dash, A2, B2, C2, A3, B3, C3. Fine. So you can separate these two. The determinant will remain same. Next property is that if you have a lower triangular, upper triangular determinant, like these elements are 0 for a 3 cross 3 matrix, and these are A, B, C, D, E, F. So no matter what these elements are, you will always have the determinant equals to the multiplication of the diagonal elements, that is A, B, C. Fine. Same for the lower triangular matrix, that if you have A, B, C here, D, E, F here, so no matter what these 3 are, your determinant will be from these 3 only. So this implies determinant is also A, B, C here. Fine. So this is one of the important properties. Now we are going to move on to the system of the homogeneous linear equations. Okay. So system of homogeneous linear equation. Mainly the question is asked from this section only, so we are going to focus on this because all the other stuff is too easy and we can use that in this also. So that's why. So A1x plus B1y plus C1z is equals to 0. This implies homogeneous. If it is something else than 0, then it is not homogeneous. Then you have A2x plus B2y plus C2z is equals to 0. A3x plus B3y plus C3z is equals to 0. Fine. So you have three equations, three homogeneous linear equations, and the condition is they will have a trivial solution if trivial solution means that at least one of x comma y comma z is non-zero. Not all the three are zero. Okay. So this is if delta is equals to 0, and delta, where the delta is made from the equations. Okay. So a1, a2, a3, these are the coefficients of x, y and z. b1, b2, b3 and c1, c2, c3. Fine. So this is delta. If this is equals to 0, this implies that this system of equations which we discussed above has a trivial solution. That is, at least one of the x, y, z is not 0. Again, the second case is, what if the delta is not equals to 0? This was when delta is equals to 0. What if delta is not equals to 0? If delta is not equals to 0, then x is equals to y is equals to z is equals to 0 is the only solution for the above system, or you can of linear equation, linear homogeneous equations. Fine. So this is something about when delta is 0 and delta is not 0. These are the two conditions. Next is Cramer's rule, which is also one of the favorite topics for JEE examiners. Cramer's rule state that first condition, if the determinant is not equals to 0, okay, then the solution to system of non-homogeneous, in this case we have some constant instead of 0 in these equations. So non-homogeneous linear, of course, linear equations, then linear equations, let's say a1x plus b1y plus c1z is equals to d1. Instead of that 0, we have d1 here, d1, d2, d3. a2x plus b2y plus c2z is equals to d2, and a3x plus b3y plus c3z is equals to d3. So we have this type of linear equations, and here is what we are going to write is solution. The solution to this system of non-homogeneous, because of these three, because they are not 0, so that's why non-homogeneous. So the solution will be x is equals to delta 1 by delta, y is equals to delta 2 by delta, and z is equals to delta 3 by delta. You can write hat here. It's not meaningless, but it's a meaningless thing, but you get the answers as the solution for this system of non-homogeneous linear equations. So the next point is that where of course the delta 1 is d1, d2 and d3. Sorry. Then b1, b2, b3, c1, c2, c3. So instead of that first column of a1, a2, a3, we have written these three things, d1, d2 and d3. That's for delta 1. If you want to calculate delta 2, then you will replace d1, d2, d3 for b1, b2, b3. If you want to calculate delta 3, then you will replace c1, c2, c3 to d1, d2, d3. And these two will remain same, a1, a2, a3 and b1, b2, b3. So this is how we calculate delta 1, delta 2 and delta 3. Then we divide by delta, which is, delta is of course a1, b1, c1, then a3, b3, c3 and a2, b2, c2. This is delta. So we calculate the value of delta 1, we calculate the value of delta 2 and we get delta 1 by delta 2 is equals to x, which is the solution for this linear equation. This is the condition when delta is not equals to 0, because we are dividing with delta here. So delta must not be equals to 0. What if the delta is equal to 0? We are going to discuss that condition now. If delta is equals to 0 in this non-homogeneous linear equations, then, and of course one more condition, that delta 1 is equals to delta 2 is equals to delta 3 is equals to 0, they are also 0. Then what? Then we have infinite number of solutions. What if delta is equals to 0 but at least one of the delta 1, delta 2 and delta 3 is non-zero? In this case they were all the three were 0, but what if at least one of them is not 0? Then we have, this is the most important condition, no solution, because many a times this situation arises. So first of all check this one, then this one, then the, of course delta you will check first of all. If you have the first condition, delta not equals to 0, then you will move on to delta 1, calculating delta 1, delta 2, delta 3, calculating the value of them, and then the value of x, y and z. Fine. But if you have delta equals to 0, first check this one condition, because this is most of the times this is true. So that's why you have no solution. Okay. So here we complete our matrices and determinant part.